Previously, on this Ain't AI, we talked about what an LM actually is, a big fancy guessing machine that don't think, don't feel, and sure as hell don't understand. But if you're going to use one, you better know how it actually works under the hood. So in this part, we're popping the hood, pulling the cover off the processor, and showing you what's really going on when the machine starts talking. Grab a wrench. We're talking tokens inference, and how a bunch of math tricks can fake the sound of a real thought. Now, let's get into it. All right, so now you know this thing ain't AI. It ain't brain. It's a guessing machine. But how does it do that guessing? How does it go from your words to something that sounds like a person had a thought? Let's break it down. We're talking tokens inference and how the machine fakes thinking like it means it. First up, tokens. You might think an LLM reads sentences like you do, word by word, idea by idea. Nope. What it sees is tokens, chunks of text. Could be a whole word, could be part of a word, could be a space, a period, a weird emoji, or just cue from questionable life choice. A sentence like "let's go get tacos" might break down into 6 tokens or 10, depends on the tokenizer. So when you type something in, the model don't see language. It sees numbers. A list of tokenides, all mapped to learn patterns from training. Now, here's where it gets spicy. Once it has your input as tokens, it runs inference, which is just a fancy word for guessing what comes next. It takes that list and runs it through a giant pile of math, matrix multiplications, activation weights, activation functions, a whole neural circus. What it's doing is building a probability map, a list of all the possible next tokens, with a percentage next to each one. So let's say you prompt it with, "The wizard walked into the model might predict room 43%, castle 29%, bathard are short, 7%, Pizza Hut 0.2%, blender 0.00001%, but it still could happen." Then, based on the generation settings, like temperature, top K, and top P, it picks one. That's inference, and it repeats this process over and over for each next token. Oh no, it's not writing a paragraph. It's picking one word, then another, like laying track while the train's already moving. Now, if you're really trying to control this thing, there's one more trick. It's called the seed, a number that locks the randomness in place. Set the same seed, same prompt, same settings, you'll get the same output every time. Change the seed, whole new result. Same vibe, different path. It's like rolling loaded dice, but you get to pick how they're loaded. Wanna debug? Set the seed. Wanna generate 10 drafts that don't overlap? Change the seed every time. Nobody talks about it, but if you're doing real work with an LM, that seed matters. Now, here's the real kicker. Structure of your prompt changes everything. Put a period instead of a comma, different result. Add a few words of context. Might stay on topic. Forget to include tone cues. You're getting Shakespeare when you wanted Brooklyn trash talk. Because again, the model doesn't know what you meant. It only knows what people sounded like when they wrote similar patterns. And those patterns, that's all it's got. No awareness, no memory of truth, no little robot in a chair watching the words go by. It's just math. Deep, stacked, recursive math. Fancy term is autoregressive decoding. I call it talking with statistical anxiety. So let me make this real simple. When you ask a question, the model don't answer. It completes. When you write a prompt, it don't respond. It continues the pattern. That's why if your prompt is vague, wrong, or misleading, the output will be too. It ain't broken. It's just doing what it was told. And if you told it wrong, that's on you, not it. Now, why does this matter? Because the entire point of using an LLM is learning how to control the input to get you useful output. It's not a conversation, it's a dance, and you're the one leading. You learn to write for the machine, you get gold, you treat it like a mind, you get soup. Not even the good kind of soup. You get lukewarm, chunky, nonsense soup with sprinkles of truth and a whisper of Wikipedia. So when someone asks, what does an LM actually see? You tell them it sees tokens. It maps probabilities. It plays pattern matching like a game show contestant on no sleep. And it don't know anything. But it's real good at sounding like it does. And that's what you're working with. Now refill your mug. Next up, we talk generation settings and how to steer this thing without driving it into a wall. Rotgut out.